Start. So as president of this jury, I'm quite happy to be here. I've been here a few times, and I'm quite happy to hear more about the work from Praveen in that BI for People project. I already know, and I am with Anne Nazag, who is online, who acted as an external reviewer from Sorbonne Paris Nord University, and Professor Arnaud Salaberry from Montpellier. So they both reviewed the thesis. And we have a special team of 3 co-advisors. This is, you were lucky, huh?
Yeah,
You're lucky,
very lucky.
And with Fatma Bouali, who came from Lille, she's professor in Lille, and Cyril Runs, who's maîtresse de conférence in Tours.
Absolutely.
And Gilles Venturini, whom I know for quite a few years now. So we're happy to hear you for 45 minutes,
Yes.
let's say, and afterwards we'll have a bunch of questions for you, I'm pretty sure.
Okay.
So please.
Okay. So, hello everyone. First, my name is Praveen SONI. Today I'm presenting my PhD thesis. Before I moving forward, I would like to thank all the jury members for giving me this opportunity. Moving forward with the thesis. So, name of our thesis is Automatic Generation of Dashboard. So during whole presentation, I will follow this overview, starting with the introduction and then followed by state of the art, and I will end with the conclusion perspective, followed by with your question answers. So let's begin with the introduction. So data visualization, dashboard, and its importance. So when we talk about the data visualization, it is very important to visualize all the data, and dashboards come in existence. So first we will understand what is dashboard. So dashboard is basically when there is more than one visualizations present on a screen, we consider as a dashboard. There are different definitions given by different authors. But now we will understand the importance of the dashboard. Basically, dashboard help us to consolidate the data and present the information from the database or the files. Then it also helps us to present different types of the patterns, like with the help of the scatter plot and other visualizations. And more importantly, it saves our time, as well as it helps us to make the decisions with the help of the visualization what is present on the dashboard. Moving forward, we will also see how dashboards are created. Because if we talk about the dashboard, it is important to understand how dashboard created manually as well as automatic. So if I talk about the dashboard created manually, so when there is no user when there is a user intervention, maximum or minimum, we consider the dashboard which are created manually. In such kind of the creation, there is certain no use of any particular methods or algorithms. What on the other side, if we talk about the automatic generation, in that case, we will use certain algorithms or methods, but at the same time, there will be minimal or no use of the user intervention. Now, if I talk about these user types, so there are 3 different types of the users we have categorized, like starting with the experts. So we consider the experts like professor, researchers, or data scientists, and they are easier and familiar with both types of the tools, like commercial or academics. Now, moving second, which is learners. So basically, over here, we consider the students, which can be recent graduate, masters, or bachelor students. Most of them you will find they either use the commercial tools, and if I take say commercial like Power BI, Tableau, or something like this. But still the question comes for the novices. Is there any tool for them? No. So we come into existence about the system that we have developed. And when I talk about the novices, so it is more about like shopkeepers or street vendors or like people who don't know more about the tech. Now, if I talk about the thesis, how it comes. So basically, this whole thesis is a part of a BI for People project. In this whole project, which was divided into 7 packages, if I talk about the problem of this project basically to develop a tool which can be easily accessed and used by the novices for the analysis of the data set. Out of these 7 work packages, my work package is the 4, and which is automatic generation of dashboard. Now, I will talk more about the thesis objectives and goals before moving forward. So if I talk about the thesis objective and goals, it is very important for us to focus on the simplicity, because we are more focused on the novices part. So we focus on the simplicity as well as simple terminologies. Apart from this, The first one is, if I see the fast and quick dashboard recommendation. After that, I will say, as we consider the novices, so it is more importantly that our system should be completely automatic. If there is any user intervention, it should be minimum or no user intervention, or it should be optional so that they can skip it. Now, I will talk about the feedback integration of the users in our system. So we have a system feedback integration as well as rating system. So that user can rate it and give the feedback and then regenerate the dashboards or more visualizations. Now, if I talk about the simplicity, so B considers the simple visualization which can be easily understood by the novice especially. Last but not least, there are many tools which are already present, academics as well as commercial, but they are paid. But our objective is to present the tools which should be accessible free of cost. Now, next I will move forward with the state of the art. So during whole research, we first worked on the survey part. And in this survey, we explore different sources like Google Scholar, IEEE, and many SCI and many others. During this research work, we find around more than 1,000 articles. And finally, we access around more than 150 articles. After that, for the free access based on the qualitative analysis, we gone through around 68 articles, and finally we consider 50 articles. Out of these 50 articles, we found there are 19 automatic dashboard recommendation systems. And then we make all these systems analysis across 8 different dimensions that we can see over here. When I talk about the 8 different dimensions, first we classify in a broad way, like work origin, then suggestions of visualization, layout, and later user point of view. Out of these 4 different broad classification, we went into more deep and we classify further. Like first dimension is the year. There is total 19 years from 2024 to 2021. So we can see how earlier such kind of the system begin and how recent analysis be done. Next is consider visualization. So there are around 15 types of the visualizations that we found, like line chart, pie chart, and many others. And then it comes about the suggestion mechanism that we will talk in the next slide in more detail. Apart from this, there are utility functions. We found around 14 utility functions. Out of them, most are present in SK Explorer system. Next is the layout. We found 3 different types of the layout, like imposed layouts, optimized layout, and manual layout. Next is the feedback, user feedback. So we found there are 2 types of the user feedback. One can be behavior based and second can be direct feedback. Now, if I talk about the user interface, so there is features like drag and drop and selection mechanism. So there is 2 types of the user interface. Last but not least is more about the license. So we found there are 3 different types of the license, like freeware, commercial, as well as open source. These are the 3 different types. Now, if I move about the system analysis, so as I explained, there are 19 systems. All these 19 systems are analyzed across 8 different dimensions. I will not go in much detail about this. So these are 8 different dimensions. Now, as I told about the automatic algorithm that we found for the automatic or semi-automatic generation. So first we find the statistical properties, but there is some drawback that we found, like it takes a lot of time. That is the computational time. Next one is the machine learning. So in case of the machine learning, we include deep learning as well as neural networks. Some of the system use them, but again, there are drawback, like we can say they need training time for model, as well as they also need that they need to collect the data sets to train the models. Next one is the visualization query language, VQL. So basically VQL, for that you need to have some knowledge base, and addition to it, you have to maintain it from top to bottom hierarchy. There is some miscellaneous kind of the methods or algorithm we found, like heuristic, template based, or the direct matching. So these are all about the different algorithms and methods we found. Now, if I talk about the existing systems evaluation, we don't found any certain system or algorithm through which we can make the analysis of all the system together. But through the outcomes, what we found in different survey papers or different systems, there are 7 systems which perform the system testing, but there are 4 systems which perform the comparative study. Like for example, Voyager 2 perform the comparative study with the whole star, while at the same time, Calliope perform the comparative study with the data sort. There are 5 systems which are commercial, but none of them perform any kind of the system testing except Tableau. There are 3 systems which do not perform any kind of the system testings, which is Drago, Escape Explorer, as well as Dashboard. So now I will move forward to the genetic algorithm, which is one of the backbone of our algorithm which we used in our system. So we will see before moving how genetic algorithm work, how our system completely work. So we will see the system workflow. First, we will take the data set and we consider that data set is pre-processed. A user can pick up from the inbuilt data set in a system. Then there are 4 different types of the model. So we will see them one by one, like data model. So basically what the data model do, it helps us to find which kind of the data type present in that particular data set. So data type. Then second is the task model. Basically what the task model do, it helps user to identify the value from 0 to 100, or they can assign a kind of the user importance. Next is the user model. So in user model, user can give his expertise, like his novices, learner, or expert. He also define the number of visualization he want in that particular dashboard in a recommendation, or which kind of the visualization, like pie chart, scatter plot, he wish to present in a dashboard. Next one is the visualization model. Visualization model is very important because it decides the feasibility of that particular or certain visualization based on the mapping between visual attribute and data attribute. If that particular certain type of the mapping perform, then only that particular visualization will be able to be present in dashboard. When these all 4 model works together, then our system get some recommendation. Then we will put the optimal dashboard and optimized layout, and we present that particular dashboard in form of the Vega Lite. That Vega Lite code will be presented finally on the GUI, graphical user interface, so that user can interact. Last but not least, user can give the feedback and again regenerate the other different dashboard if he or she not satisfied. Now moving about the GA. So there are different algorithms that we could use, but why we choose the GA? We find different algorithms like heuristic, meta heuristic, and others, but we chosen the heuristic because it is more general to and not particular to the problem. Then in heuristic, we more focused on the randomized because we need to focus on the different random generator. Then if I talk about randomized, there are different algorithms like hill climber, simulating annealing, and genetic algorithm. We discard the hill climber because of the problem local minima, but we have chosen the genetic algorithm because of its important features, like it is help us to multimodal, which means it help us to find the particular optimal solution. In addition to it give these suboptimal and optimal solutions. Then it helps us also integrate the user choice, so user can put the seed in the population and get that particular outcomes in the optimal solution. Next, last but not least, ease of parallelize. In a single generation, there can be the multiple solutions. Now here I will try to present how GA works. So first is the random generator. So basically in random generator, we will generate certain dashboard as a population randomly. What the system do? First, it will choose the visualizations. Let's say there should be the 5 visualization in a dashboard. Then it will pick randomly one out of, in the list of the 6 visualization in our system. It can randomly pick one of them, like line chart, pie chart. In this way, it will create the dashboard, and this dashboard will be the in a population. Next, out of this population, we will randomly select 2 pairs. The pair 1, let's say A and B, and pair 2, let's say C and D. Each of these pairs, we will select one of the dashboard or the individual, we can say, on based of binary tournament. Let's say in pair 1, we have selected the A, and pair 2, we selected D. And then we will perform the crossover. Once the crossover will be performed, and after that, we will do the mutation. And after crossover, we will got the two offspring, let's say offspring 1 and 2, and then randomly we will select out of them, let's say offspring 1. After that, we will perform the mutation. And in mutation, we can do in 3 ways. The first is can be add visualization, second can be remove visualization, and last but not least is the mapping. In mapping, again, mapping will be happen between the visual attribute and data attribute. After mutate, let's say offspring 1, we will evaluate the muted individual and then compare it with the worst individual present in the population. If the fitness value of the muted individual or offspring is greater than the worst individual present in the population, then replacement will be executed over here. Otherwise, replacement will not execute. It will again region, the GA will region. This is how the GA works. Now moving forward, I will talk about the visualization model. So how the visualization model works. So we will consider the example starting with the pie chart. You can see in the yellow part on the top. So for this particular on the pie chart, we need a certain let's say data attribute stage ID. Okay, so we will see here fourth column, the VAT visual attribute type, and the fifth column corresponding data attribute type. So here for the pie chart, we need at least one color hue. Categorical. In that case, we need defined like ordinal or nominal. In this case, we need the ordinal. So it means there should be at least one nominal data attribute type must be present in data set to make the feasibility of the pie chart. In the similar way, we can see the bar chart ordinal as well as the scatter plot ordinal. For that, for bar chart, we need one categorical, that is the stage ID, and one numeric. In case of the scatter plot, we need one x-axis and y-axis and one categorical. So on x-axis, we have the discussion, and y-axis, we have the age hands, which both are numerical, while here the ligand, that is the class, which is categorical. So this is how the feasibility works for each of the visualization. Now I will more talk about the genetic representation of the dashboard. So again, to understand the genetic algorithm, we can consider the example. And before moving the example, I will talk about the genes and chromosomes. In our genetic representation, we consider the dashboard as a chromosome, while others like we can say visualization, visual attribute, or data attribute, we consider them as a genes, small genes or big genes. Now moving forward with the example of this particular dashboard, which is a genetic representation. So first we will talk about the scatter plot. So in scatter plot, on the x-axis, we consider the sepal length of the IS dataset, and on the y-axis, we have the petal width. So you can see the X color is mapped, which is the visual attribute with the sepal width, while petal width, which is mapped with the y-axis or visual attribute. The species over here, it is mapped with the color, or I can say ligand. In the same way, it works for the pie chart, like we need only one attribute, that is the color. For bar chart also, and for histogram, you can see the mapping is done with the x-axis with the petal width, which is numeric. So now I will more focused and present about the crossover. So in case of the crossover, we need at least two parents, like parents A and parent B that we consider earlier. So in parents A, we consider there will be at least two. There should be at least two visualizations. One is the scatter plot and other is the bar chart. While on the second side, parent D, there are 5 visualizations. So what happened basically in this particular case, there are a cutting point that we have to decide. The cutting point will be decided randomly considering the length of the dashboard. So here the cutting point is between two. Okay, the first one. So the top part of the dashboard, that is the parent A, will be mapped with the second part of the parent D. And the second part of the parent D in the green color, which is bar chart, will be mapped with the first part of the parent D. So here you can see on the bottom, two offspring will be generated, like a scatter plot, which came from here, parent A, and the last four over here, it came from the parent D, and the vice versa. Then we got these two types of the offspring. Now we have randomly selected one of them, let's say offspring 1. So how the mapping and other mutation like add and remove visualization done or happen, we can see here one by one. First, we will talk about the mapping. For happening the mapping, it is very important when there is certain type of the data attribute or visual attribute want to map with the other types, it should be the same type. Like in case of the scatter plot, we can say see A3, which is nominal, and A4 is also nominal. So A3 is mapped from A4, which is color. And in the same way, pie chart, which is A1 is numeric and A2 also numeric. Again, it got mapped from X is mapped with the A2, A1 from A2. The last in the bar chart, the color is mapped, which is visual attribute with the A4. So this, but at the same time, you can see there is no mapping in the pie chart and as well as in the histogram, because we have implemented it on the random basis. So some of them happen, some of them not. Now moving forward about the two different other types. One is the added visualization. So in add visualization, we will pick one of the visualization from the list randomly. So here histogram is selected and we add one visualization. So now here is the sixth visualization. While in the remove visualization, we can see we remove this pie chart, which is in the offspring. Now there is only 4 visualizations. So one visualization got removed from between the scatter plot and the bar chart. So this is how the mutation executed. So now I will more detail about the fitness function or the evaluation function that we used. So the fitness function is basically a combination of the 3 different parameters. One is the match score, second is the coverage, and last is the complexity. And each of them have their coefficient. Now we will see all of these 3 parameters in more detail. Now we will see what is match score. So basically, match score is the mapping between the visual attribute as well as with the data attribute. And in that case, we have used the McKinley matrix to compute the value of the match score. In terms of the mathematics or mathematical, we can say it is the sum of the matching quality values that we found using the McKinley matrix divided by number of visual attribute present in a visualization and into 100. Now, second is the coverage importance. So basically, coverage importance, we can see here is the user importance that is given by the user, like 75, 50, and 50 is by default, 25, 100. And we will make the sum of all these 5 and sum of all the important total number of data attribute present, like 5 and into 100. So this is how we coverage importance calculate. Last but not least is the complexity. So complexity is defined based on the user knowledge or our knowledge base. Like for histogram or simple bar, we consider they are less complex. While scatter plot and bar chart, we consider they are more complex. So we make all sum of complexity of all the visualizations that are present in a dashboard into divide by total number of visualization into 100. And we consider the maximum complexity can be 100. Now I will talk about the coefficient alpha, beta, and gamma. As I say, based on the complexity, we found different users have their different level of expertise. So here we consider for novice is 1, but for beginner, different visualization are not that much complex. So we reduce the complexity at 0.5 as a coefficient. While for expert, we consider for them all visualization are same because they are expert. So we consider 0.1 a very lower value. Now I will talk about the evaluation of fitness run. So how much time it takes to run particular GA. So we found that the fitness function is very fast in terms of the computation, and around 14,000 fitness functions or fitness evaluation are performed in a 1 second, which means we consider a population of the 50 dashboard having the generation 20,000, which run within 6.4 seconds. So we can say GA works too fast. Now here is a sample of the dashboard that got generated. Like one point I would like to highlight, there is sample width, which means 0. It means we can exclude, we don't want that particular data attribute in the dashboard. So you will not find the sample width over here. So user can define which kind of the visualization or importance they want to see. Now, to understand what is the good population and what is the good number of the generation, we perform the grid search to study these parameters. So grid search was performed here. You can see on the columns, this is the population size like 10, 20, 30, and up to 100. And here is the generation on the rows, 1,000 to 20,000. And we found over here when there is a dash population size is 50 and number of generation is 20K is the best fitness value, that is 0.699 with the standard deviation 0.299. And this value, if I will explain, it is the average fitness over 10 runs of the best individual found in each run. And this is in bracket, it is the standard deviation of this. Now, I would like to compare two different dashboards, one which generated after GA and the one that got generated during the our random by the random generator in the initial population. So here on the left, you can see the initial dashboard, which is come from the initial population. On the right, we can see the dashboard after GA. Now we will compare their efficiency based on the fitness value. So the dashboard in our initial population have very lower, like 0.099, while dashboard after GA, you can see the difference, it is 7 times, 0.729. It is not just about the value or the fitness value, it's also about the number of data attribute covered. Like after GA dashboard, it contains 11 total number of data attribute, while the initial one contains only 9. So we can see the coverage. Now I will move to the SimpleVis user interface. So we will see here system design part. So to design the system, I consider the important parameter, that is the user type, starting with the novices, common users, and expert, where we define the different features, consider the users. Like for novices, our objective is to see that system should be simple with fewer efforts, as well as it should be completely automatic. While for there should be the option like a parameter setting, which can be easier done with the help by the users like common users and expert. Some features like simple terminology interface should be interactive for the users, and there should be manual editing of the visualization, which can easily done by the common users and novices. But there is certain advanced feature like editing or the change modification in the GA genetic algorithms, as well as fitness function, so which can be only executable by the expert people. Now, next one, last but not least, there is a common features like fast and quick, independent of the users. All users want to be fast and quick. There should be the better, more than one of at least 5 best dashboard should be recommended. Every user want there should be feedback should be taken into account to get the better dashboard. Optional manual editing, such features available for all types of the users, and customized and personalized dashboard generation. So these are the features which can be accessed by all any type of the user. Now I will focus about the system architecture. So basically, if I talk about the system architecture, our first focus is it should be quick and fast, which means it should be get done in 3 simple steps within or less than a minute. So the first screen we will see here data upload, or we can upload the new data set or select from the pre-processed one or inbuilt data set. Next one is the metadata. Here user can set their preferences. We can see it in more detail in data and demo part. And the main dashboard, the different types of the dashboard will be here, or a personalized dashboard can be created. So user can make the exploration of the dashboard in the last step. If I talk about the text selection, so we have used the Nest.js for the front end side, Vega Lite for the rendering of the visualizations from the genetic representation to visualization, and Node.js we have used for the backend part because it is quite fast. Now I will try to present the demo part over here, how the SimpleVis tool basically works. So here you can see you can upload the data set or you can choose the existing data set. I will consider as a user that I am novices. So how system works for the novices. Let's say I select for the student. Okay. So data is uploading. It will take not much time. So you can see the second screen basically. Now I will not make any change because I'm novices. I just click. So random generator is running. Now GA is running. So that's what is generating. So important thing that I would like to present here, just within the 15 seconds, our dashboard is generated. And not only one, there are different 5 types of the dashboard got generated for the novices. So it is very quick. Now, if I consider that I'm beginner, I will try to make the change in the dashboard data attribute important. Let's say I don't want the gender over here. Okay. And I want nationality should be present. And let's say I want, you can say place of birth, I can remove completely. Okay. Over here it is already. And I can make one more change. The relationship should be over here. And after that, I can also make the selection of the visualization. Okay. And number of visualization also. Let's say I will consider as a 6. Now I will reason here. You will see the difference. So again, random generator is running. And then GA is working. And we got again here. So we can see the nationality as we have assigned here 100. We can see it is over here. The best thing about here, we can change. Just suppose I am unable to understand the bar chart. I can simplify. I can just click over here. This visualization will be changed into pie chart. So you consider here, you consider here the nationality is already here. Just is changed from simple bar to the pie chart. Now I can also able to create the personalized dashboard over here. If I go here, so what I will do, I will add it. Okay. I will also add this particular visualization. I can add the bar chart. I can lock it. Okay. And then I want some visualization to be created from other dashboard. So what I will do, I will add this one like raise hand. I don't. So a new personalized dashboard got created. I want to add this simple bar. I will add here. If I want to add one more this particular visualization, I can add. This is how particular personalized dashboard generation works. Now I will try to present other like manual editing part. So for that I will consider that I will change the user type. And for the moment I was novices. Now when I change from novices to expert, you will see here is the difference. Like now bar chart and scatter plot also get selected. So I will again just click over here and regenerate the dashboard as the expert. You can see they said the line chart is not possible. It is because for line chart we need the temporal, and temporal is not present over there. So that's why line chart is not visible. So here you can see scatter plot. Also the complex bars are over here. Now I will show you the manual editing for the scatter plot. Last time I have seen from simple bar to the pie chart. Here I will not change the visualization. I will change the attribute. I click over here. I say, okay, on axis, visual attribute resource is fine. By also fine discussion. I want to change this particular relation. Okay. I will apply over here. And now parents answer survey will be changed to relation. You can see it's changed over here. So for other features, like I can perform the GA manual editing over here, which operator I want. I can also change the fitness function coefficients. And more importantly, is the rating system. If I want a particular suggestion, I can select over here. First one, I can select the fourth one. Visualization are too complex to understand. And seventh one, visualization looks very similar. Then I will submit. So here is the solution for all 3 problems I have presented. Now I will not go in much detail about different other features. So if I want to exit, I will exit. And they ask for the feedback. I say yes. I can give the feedback over here, and I can submit. So now moving back to the presentation, basically, so we will see here or the system evaluation. To understand the system, we perform the comparative study. And for the comparative study, we have chosen the particular way, that is the different types of the participant. And in participant, we found around 27 participants, and there are 18 male and 7 female, and the age group is between 20 to 29. The mean we can say 21.48. We also asked few questions to understand their level of study, and we found there are 18 bachelor's students, 2 master, 1 corporate, and 4 corporate, 1 doctorate, and 4 corporate employees. We found there are 11 novices users who are not familiar with any kind of the BI tool, but there are 14 participants who are familiar with certain kind of the BI tools. In case of the data set, we have chosen the 5 data set. One is the ICE, which is used for the training part. And for the task 1, we consider car and weather. For the task 2, we consider wine and crop. But we consider with same number of attribute and its type for task 1 and task 2. Now, if I talk about the evaluation protocol, so we have given 2 types of the task. The task 1 is about the exploratory task. We ask the user that you can just automatically generate the dashboard, but there should be all the visualizations which are present in a data set must be present in the generated dashboard. While in the task 2, we ask them there should be at least 2 scatter plot in the generated dashboard. If not, they can perform the manual editing. There are certain tools which are 2, like SimpleVis and Power BI. Both the tasks are performed, both of them one by one. And we follow the certain steps like welcome and general introduction, fill the participant basic details, training, and then perform both the tasks one by one. Then SimpleVis and Power BI, and they can select the tool randomly. And finally, we ask for the feedback and we ask them for the fill the questionnaire form. This whole study lasts for 72 minutes. Now, if I talk about the results analysis, so basically the results analysis is performed on 2 ways. One is the task based, other is user type based, and then both of these are analyzed on 2 dimensions. One is the time, other is the quality. In terms of the time, we have used like aggregation operators like mean, standard deviation, and student t-test, that is p-value, and finally present them with the box plot. For the quality, again, we have used the same like mean, standard deviation, and p-value. And the same thing we perform for user type based also. Now here, if I talk about the task based, so for time and analysis, as we can see here, the p-value for the task 1 in terms of the time, the p-value is less than 0.5. So there is a significant difference, and we found the SimpleVis is faster than the Power BI. So the conclusion of whole task 1, we can say SimpleVis is faster than Power BI and obtain the similar quality of results for not only the task 1 but also for the task 2. Now here we present the results graphically with the help of the box plot. The same thing. Now second is the analysis based on the user type, the time and quality. So for the task 1, again we can see here about the value, and novices almost perform the similar to the experience. And the conclusion of the task 1, we found novices take the similar time and obtain the similar results. So both the tools, Power BI as well as SimpleVis. While in case of the task 2, we found here experience takes more time than novices, and they have the better quality than novices. The reason behind, because novices cannot learn quickly the tools like which are complex like Power BI, and they give up quickly because they are not experienced with certain type of the tools. While in case of the other with SimpleVis, novices take the similar time to obtain the similar quality of results with the SimpleVis. Now, in case of the questionnaire analysis, we have given the 11 question to the to participants, and we found here based on this mean and standard deviation, SimpleVis is slightly more useful and easier to do the task, and at the same time, SimpleVis is faster and easier to use and learn. While on the right side, we can say out of these questions, the question number 8, which perform the manual editing or which support more manual editing, we find over here that Power BI support more manual editing, while SimpleVis is more simulating and interactive. Last but not least, mostly we found Power BI is useful for the experience. Now, if I conclude the study of this particular evaluation, so we found here that SimpleVis is interactive because its feature like it make the more intuitive and give the initial automation as well as minimum intervention or minimal manual effort. The SimpleVis is completely fast and very completely automatic, and it not only for novices, also support other users, so it like different level of users. While at the same time, Power BI is quite more useful for the experts in comparison to novices because it supports highly manual editing and difficult to use, and it is quite good for the complex data to perform the complex data sets analysis. While in terms of the user types, novices perform better with SimpleVis because it can be easily learned and used as compared to Power BI, and SimpleVis is more user friendly and interactive. So last but not least is the conclusion and perspective what we identify. So the conclusion we found that the problem we identify is the lack of automatic dashboard recommendation system, which is could be explicit preference based optimization for expert and optional manual editing. So we start with the literature review on the automatic dashboard generation, and we find the system generation through the genetic algorithm and generate the dashboard which should be optimized. We contribute in the field with the help of proposing the SimpleVis as a tool which support the dashboard automation, the automatic recommendation. And then SimpleVis is not just about generating the dashboard automatically, but it also support the adaptive user preferences based optional manual editing. In addition, last but not least, we validate our research as well as the system with the comparative study. So it is not just about the theoretical part, but also practical and its relevance for the novices and other users. So now I will talk about the system perspective. So we have defined the system perspective in two parts. One is the short-term perspective and other is the long-term perspective. First, we will see the short-term perspective. So in short term, we find we can enhance the automation by and more user interactivity by two ways. One, automatic selection of the data attribute by mapping with their data attribute type. Second, the feedback integration should be automatic instead of the manually. Second is accommodating more complex data set and diverse analysis need. Like for the moment, we are limited to only 6 different types of the visualization, but we can go beyond like map, radar chart, and many others, them like box plot also. Last but not least is the enhanced analytical capabilities by empowering users to uncover more profound insight. Like we can add more aggregation operators, sum, mean, median, as well as we can use some user interface effects like brushing, linkage, and annotation. Now here is the system perspective for the long term. So user-based recommendation enhancement. So in that case, we can work more about the history-based recommendation. So if user already make some projects with our system, it can be recommended again based on that, like ChatGPT work basically. Also, predefined template proposition can also be proposed based on different domain like medical or sport or something like this. In addition to this, we can see integration into the third-party business tool, like we can give the open API so that people can add in their ERP and other different tools. Now, if I talk about the optimization algorithm and about fitness function improvements, so we can enhance the GA as well as fitness function by making the modification coefficient and other better beyond the different 3 parameter, maybe new 4th or 5th one. And then also we can talk about the global optimization of the dashboard. We can see how better we can organize the dashboard. So great thanks to my supervisor for supervising me and during all these 3 years. I am very lucky for that. And now we will talk about the use case presentation. So as I already show you the 3 use cases, but in novices we go in more details, like 3 different types of the use cases. In expert, we present the 2 types of the use cases. In total, we have the different 5 types of the use cases. So here I will talk about my publications and other work. So basically, we publish around 4 articles in different venues. One is the survey article, which is a survey where we analyze the 19 systems across 8 dimensions. Second, I presented in a IB conference in Finland about the genetic algorithm for the automatic generation. There is 2 different more research work that we have presented into the national conferences. And the last one we are planning to write and submit in some good journal. It will be the complete system paper. Now, if I talk about the courses and credit, so I have obtained around 55 credits and different courses, like especially in entrepreneurship and other different courses. So thank you so much. Here's the last slide. So I'm ready for your questions, and thank you so much for your time and listening.
Thanks for delivering and talking the lot of the time frame. So now I would like to invite, well, first the reviewers to ask the questions, and we'll start with Professor Azag from Paris. Can we bring Professor Azag back on the screen? Or no? And then you click the button, so maybe we see you while you ask questions.
Okay, thank you, Guy. Thank you, Praveen, for the clear presentation of your work. You propose a recommendation system to create a dashboard. Your solution use an original method that use genetic algorithm. Your report was easy to read, but the many abbreviation you used made it a bit harder for me. But I have appreciate your large and detailed state of art.
Okay.
So for with my questions. First, in chapter 3, you present your solution for generating dashboard using genetic algorithm. You have coded the different visualization and defined a fitness function.
Yes.
So here, do the value of alpha and beta change in the genetic algorithm?
Yes.
Yes. Why did you fix
Okay.
them at 1 and 2? So I don't understand the process that you have used to fix alpha and beta to 1 and 2. Slide 23, I think.
Basically, to explain this part, we have to put certain coefficient. I will begin with the gamma because it is very important where we got this idea. As I explained, for the complexity, just these are professors. For them, all the visualization are similar. But for novices, like person who is from chemistry or physics, they are not technical. Okay. For them, all visualization are not same. For them, maybe SimpleVis, pie chart, and I can say other visualization can be easier. But when it comes about scatter plot or certain other visualization, it is complex. So we consider them the visualization coefficient is higher for novices because visualization will be changed. But for the who are expert like a business analyst or something, for them it is doesn't mean any kind of the visualization can come in a dashboard. So this value gamma decide over here the coefficient of about the which visualization should be present in a dashboard. And in the same way, we put the alpha and beta so that if in case we have to change anything, we can change.
Okay. Next, in the same way, it's not clear for me when you say the crossover happened with probability of 0.35. Same case for the mutation happened with probability of 0.65. So can you explain why you use of it this choice?
Yes. So here basically we perform the different scenarios. So that this is the slide that I didn't present. So basically what we did, only crossover and add visualization, different only add visualization. So in the slide that I present in the scenario 3 in the presentation, that only considering that particular scenario which we find this particular probability. But if you go more detail about the different combination, maybe this slide you can understand. We make the different combination, only crossover, only mutation, 100%, and mutation mapping, different weightage and different combination. And finally, all these value come and we find that this particular weightage that we present, like 0.6 or and others, is quite good. So it is based on these results that we find.
It's based on the performance of the result. Okay. The population in your experimentation, the population size is fixed to 100. Okay.
Yes.
What happens if you use more than 100? It's first, and secondly, what do you think about comparing or using with generative adversarial network, GANs? I don't know if it's possible, but have you think to use? Have you looked at this type of method, deep learning method?
To be honest, no, because our more focus was to be work on the quick and fast recommendation, and we consider we could have used the deep learning. It might take for training the model and something like this. So for this certain algorithm, I will say no. And for the other part, like you have asked about the 100, so basically we do not consider more than 100 because it will again the time will increase, but somehow the fitness value is not increasing effectively that we are expecting. And you can see the results over here after 100 is decreasing.
Okay. Okay. In chapter 4, you present SimpleVis interface designed to simplify automatic recommendation, where you integrated your genetic algorithm. So here, can user recommendation improve or guide the genetic algorithm as, for example, in active learning? The recommendation of user can guide or improve the genetic algorithm.
Yes, yeah, user can improve the genetic algorithm if
yes, as in active learning.
What the last word you said?
As in active learning.
Edge?
Elective learning.
Elective learning.
Active.
Active learning. Okay, edge active learning. I think no. That's usually. If what I understood better about the active learning, wait, let me see. If we are considering these changes like coefficient and this value as if we are considering it as active learning, then I can say yes. If not, then no.
So user recommendation can modify the behavior of genetic algorithm?
Yes, user can modify the genetic, not genetic, genetic algorithm operators. Only mutation here, mapping, add visualization and remove visualization, as well as crossover. He can only decide whether crossover should be taken into account or not.
Okay, so my last question, Praveen, is in your opinion, how can SimpleVis be improved? At what level of genetic algorithm, for example? How you can improve now SimpleVis to be better?
Okay, so I can personally suggest it can be improved with the more automation, Okay. First, I will more focus on the history based. Okay. And in terms, if you are asking particular in terms of the genetic algorithm or fitness function, we don't see any more improvement. Okay. But still, we can found some more of coefficient as well as try different coefficient apart from three different parameters like match score, coverage importance, and complexity. We can find and more research about the fourth one or something fifth one, but it is the possibility, but we didn't find anything else. And second could be like coefficient changing. So we can say hit and trial again if we can get the better fitness value, or maybe some other fitness function, but we cannot say anything about this. Just I have one more point just to tell you. Earlier, when we published the paper in IB conference, the fitness value function was completely a bit different. But from last 1 year, or I can say more than 1 year, we come with this fitness function with the coefficient and some others, and we taken the McKinley matrix into account in better way. But earlier, no, when we did the first one.
Okay. Okay, thank you for me. This is my last question.
Thank you so much.
Thank you, Professor Azag. Now I turn myself to Professor Salaberi.
Thank you, President. So first of all, I would like to thank you and your supervisor for inviting me to this jury. And so I found your this very interesting. I learned a lot in the state of the art. It was very well made and very with a very strong methodology. I also found the genetic algorithm very relevant to provide the dashboard, and I found the tool, the global tool, very aesthetic and simple to use. And I suppose there must be a lot of code to provide such a tool. So it's a great work, and congratulations for that. So concerning the manuscript, I miss some details, so a lot of little things that maybe could be clarified. Some of them are the same with my colleague just before, but I will ask you some other one. Sometimes I also miss some justifications of things, so I will ask a few questions about that. And after I will finish with more general questions. So the first one is also about the fitness function. So you explain for gamma, alpha, beta, and gamma. Why do you choose? I think the rationale is okay. So I think I understood why you put these values. But I was wondering on the complexity score, to compute the complexity score, you assign some complexity score to all the validations.
110 the minimum, and then up to 100, but the maximum we consider 90. 90 is the maximum for a scatter plot by a chart like this.
Okay.
Yes, 10, 20, 30, 40, 50, 60, like this.
And how do you choose the values for novice?
So it is knowledge based, to be honest. Yes. For me, like simple histogram is very simple for the novices. Like if you ask the people which in comparison to scatter plots and histogram, it is very easier for novices to understand the histogram, and same pie chart also. So when value is numerical, we consider the histogram. When value is categorical, we consider the pie chart and SimpleVis.
Okay, because for me, histogram is hard to interpret. Scatter plot, maybe it's easier. No?
It depends on the value and what you want. If you want, like, there is, let's say, 1,000 students in a class, and we want to find what is the average value, okay? Or I want how many students score in maths between 10 to 20 out of 100. Then histogram can tell us the numbers. How many students score 80 to 90 in mathematics, and there are 1,000 students, then with histogram I can see it better. In scatterplot, just it will map.
Yes.
And for scatterplot, we
So
need
for the same
at
task.
least three or at least two numeric. But in case of the histogram, one numeric data attribute is sufficient.
Mm.
So that's why we prefer for that. And one more thing, in addition to this question, you say, always there is the three visualization. These three visualization you will always see: histogram, pie chart, and SimpleVis. If we don't put these three visualization, then there is a possibility that you will not able to present a certain data attribute, because for numerical, histogram is only one for novices, and for categorical, pie chart and bar chart. And one more, I can differentiate between the pie chart and pie chart and SimpleVis. If someone is not able to understand angles, then he can see the histogram in vertical way. This is the conception we found.
Okay. And is there some study about that?
Not based on the research, but interacting with the users and understanding. I mean, I don't have a references to mention. Sorry for that.
I remember about study on this pie chart, and the conclusion was we are not actually looking at the angle, but more at the area and yes,
Area.
And okay. And so can you come back to the slide with I was wondering why 0.1 for expert on gamma, because if I understand well, the complexity score is the same for all these validations, so it doesn't change anything. You could put 0.
No, complexity score is same, but we try to minimize. Like 10, 20, 30. Okay.
Yes, but if all visualization have the same complexity score, so gamma will be for experts. Gamma will be,
but it will
for any dashboard. Gamma will have the same value.
No, so, gamma value, it depends on the user type.
No. I mean only for experts.
Only for experts.
Yes.
Yes.
Only for expert, gamma will. I mean. The last part, gamma by complexity, will give you always the same value. So you could put 0, I think, on gamma.
Then it will affect in our equation, and always the complexity will be 0.
Yes.
In terms of the code,
yes. But for expert, as the complexity is the same for all visualization.
Yeah, we can do like this also. What you are suggesting. Yes, but then in terms of the coding, it is more easier for us to put the coefficient.
Okay. Okay, thank you.
Thank you so much.
Then, yes, I miss how do you containing the cutting points.
About cutting point.
So it was not written in your manuscript, but you said it when you presented this.
Basically, okay.
Yes. So you randomly choose the cutting point on bus. I was wondering if sometimes you cannot, it cannot provide some dashboard with too much visualization. And I had the same question with the mutation operator. So when you add and don't remove, for example, how do you constrain the number of visualization, because you have a maximum of visualization?
Yeah, that I
can on the dashboard.
So first I will explain for this. So what I am doing in this, first I can consider the number of visualization, how much are present, and I will consider the minimum one. Let's say here the possible cutting point can be on parent A can be 1. Okay, if there is 1 and 1 is easily possible in the D, so the minimum one we will consider. If just suppose here is the 4 and here is the 5, then I will check there is 3 cutting point will be possible in the 4 visualizations. So 1, 2, 3, I will choose the number randomly. And that will be the minimum. Then the third, and there is 5, so it is easily possible. Now I will go your second question. So over here, so in case there are two, what I can say, exceptions that I explained in manuscript, in which case maybe mutation is not possible, because mutation is certain like mapping. Just suppose there is only one kind of the categorical data attribute, then it is not possible to map with another one. But for mapping, there will be at least two. In the same case, like for a dashboard which contain only two visualization, in that case, remove visualization is not possible, because in our case, then definition of the dashboard will be changed and there will be only one visualization if it will be removed. So in that case, we put the exceptions in the cases. So it will directly then, that's why P1 from B to H, it can go directly, skipping the mutation. And the same thing for crossover. If there is a less number of visualizations in a dashboard, then maybe crossover is not possible in some exceptions. So that's why I try to direct from B to H.
Okay. Okay, thank you. Isn't it possible to have at the end of this process a dashboard with for example, the same visualization appearing 2 times, or
It is not possible.
it is not possible
Because we make this check when the dashboard, after everything, after GA, what you said, it is very much possible. But after GA, when the dashboard is coming, we are comparing the new dashboard with the 50 dashboards. The given 50 dashboards.
Yes, I wanted to say inside the dashboard having 2 same visualization.
Yeah, same visualizations with same attribute.
Yes.
It is not possible. This is what I'm saying. After GA, it is possible. But what we are presenting here.
Oh, yes, after GA, you can have the same visualization
can
with
have
2
a
different
same,
dashboards.
yes.
Okay.
Yes. But we make the check and compare these 5, there should be no repetitions. In terms of the number of visualization, type of the visualization, same mapping with VA and visual attribute and data attribute.
Okay. Okay, thank you. Just do you have it's a very small question. Do you have the possibility to save your dashboard in maybe
Yes,
this could be used, because I have seen the export to SVG, but you can save also the
Yeah, you
dashboard.
can save, and if I will GA in the dashboard, they will not change.
Yes, but I mean when you when I hit the application and oh yes, the session with the list of
Okay, you mean again you close the application again? No, that's why that will be history based in our perspective. So you just need to create the account, log in and sign up, and you have to save the project like Power BI and Tableau. So it's a completely new feature.
That's going to be very interesting.
Yeah.
And especially for the personality.
Yes. And for that, what you said, then if we able to implement that, then we can also implement the history-based recommendation, which the chat GPT also works like on that. If you ask 3 or 4 questions, and then it will ask again after 2 or 3 days, it will take the contact from above 3 questions. Yes, the same we can implement here.
Okay, thank you. So tomorrow, I think. I found I think something that was not my in my opinion in your manuscript. It's about the standard deviation of T1 on, maybe you can put the slide 38 or 37, I can't remember. There was a standard deviation for T1 on Power BI that were 0.37 on your manuscript. I don't find it here.
Maybe there is one mistake in the manuscript, then be changed later. Maybe I don't know. And I have mail about this.
Yeah, there was this mail, but this was not in this part. It was in the text. Yeah, it's in the text. Was T1, B1.
And what about that?
Oh no, it was the global. It was not novice or expert. It was on the global result, so that's why we don't have here. Ah yes, it's here. 41 PBI, there is a standard deviation of 0.36. Yes. And for T1 SV, it is 1. Yes. Yes, I don't think you can infer from that from the results because one of the participants uploaded the wrong file.
Yes.
So that's why if this participant didn't upload the wrong file, actually T1 SV would be 0.
Yes, exactly.
Yes. So I think the conclusion you should is not that SV is less good actually. Yes.
Okay.
I think you could remove the one here because there is an outlier. Someone made a mistake. So this one
I will
has
take it.
actually no meaning.
Yeah, does that change the conclusion then?
Yes, because
you can't,
the standard
claim that
deviation
SV is similar.
the standard deviation of T1 SV is actually 0.
Okay.
Because it's just one participant who made a mistake. So I think it's an outlier.
Maybe the p-value will be enough good enough to say that later. Yeah, that's what you say.
Yeah.
But it's close.
Okay, and so my last question is about the task. So you evaluated on two tasks, and how do you choose this type in regard of the objectives of SimpleVis? Why these two one task?
Because the first task is important. Basically, SimpleVis help you to incorporate all the data attribute types which are present in that particular data set. This is one of the good feature which is not in other systems. So that motivates us, and everyone who want the analysis of the data, they want all the attributes should be over there, and then they can do the manual editing. And second, why we have chosen the second task? Because we want to also test the manual editing functionality, which is quite good or the more complicated in scatterplot in compared to other visualizations. That's why we have chosen the scatterplot to understand the solving power of complexity with the SimpleVis compared to Power BI.
Okay, I understand the rationale. Especially for T2, but what is not clear in manuscript.
And last point, especially making the scatter plot in Power BI not recommended. It's very difficult, not just because of the feature. They give a very small window which you have to find and where is that particular feature, and which is very complicated, especially for novices. This is the point they gave up over there.
Okay. And do you think these two tasks are enough to really evaluate if finally with SimpleVis, novice can better extract information for the data, or what do you think should be done to evaluate this?
If you are trying to say there is a possibility to add more tasks, then I will say already the time is 72 minutes. And if we exceed more than that by adding a new task or something, then the study will become more boring. I mean, users come with that motivation, they will not last for more longer. because especially for beginners and expert or beginners, okay, but for novices, they don't want to spend a lot of time.
But it could be in the form of another kind of
Yeah,
another
that's
type
exactly.
of evaluation, not a user story.
Yes, it could be possible. Yes, I say in that way.
Okay, thank you.
Thank you so much.
Thank you, Professor Selin. So now we'll allow myself to ask question before turning to your advisor. So I really like your work, which I wasn't aware really of, although I had reviewed the BI for People project. I think maybe it was too early, but I really like, I'm pretty sure your advisors were confident, giving you the managing the overall work package. I think you were a solid contribution to that project. And actually, what I like is that you really addressed all those questions you needed to look at in order to build that application in the end. I feel in you have some hidden engineer guy that really likes building applications, and this one is a pretty neat application. But you didn't neglect, going through all these steps, looking at the state of the art and looking at all the details of that genetic algorithm approach, which is really neat. I'll come back there. So first, the state of the art, I really like the Prisma methodology you used. This is very solid. I think our community should really systematically use that approach and methodology. I'm not sure, however, correct me if I'm wrong, because I read your thesis, but I probably didn't dig into the details as your reviewers. I'm not sure I would be able to reproduce the whole methodology. I think I'm missing a few details here and there. What the queries were for what search engine you use. Sometimes you kind of say, and there were these other things we did, but you don't provide details. Or do you in the annexes? So this is a question for me. Like, if I would like to reproduce your state-of-the-art research of papers,
Okay.
am I able, going to the thesis, to just run the same queries with the same search engine and find the same papers as you and really find all the same results?
Yes,
You have to
definitely.
make sure
Yeah,
that-
I'm confident about this.
Okay, you
Because
have to make sure.
if you want, I can show you.
I'd have to go back to the thesis, but sometimes there were like this et cetera thing.
I got
And
your
I
point.
think some details were
Maybe
hidden in
you
there.
will see this thing and you will be happy to see it. So I put all these papers like this, whatever I do, and this is all the findings. So you can see different PPT we made over here, and in every finding,
Okay.
I make a analysis of all of them.
Yeah, of course. So I can go to that documentation and really follow what you did, but I'm more interested in reproducing
Yes,
the
exactly.
same search.
So all this analysis, what the system I have mentioned, I have just not only read them, I make an analysis and important findings. I write over here like motivation of every paper, who is the author, and keywords, factors.
Yeah, that's mandatory. You have to
So
do that.
we did for around 100 papers like this.
Okay.
Yes, and for also, in addition to this, we did about the for compared
Yeah.
study part. Like as I mentioned, there are
But
four papers.
so I think I remember now. So for instance, you list all the search engines
Yes,
that
exactly.
you went at. You list all the queries you ran. But I remember, like you say, and we also consulted a few other search engines, but you don't specify which. So my question is that documented somewhere in some annex where
Actually,
you?
yes. Actually, if
So
you
you have to
remember,
do that.
there are few systems or papers they mention and they have the papers, but they don't have the systems to test.
Yeah, okay.
So for that, we mentioned that they have not given any systems and we have not tested. Like it's
Okay, but I'm not putting the papers themselves, it's how to find them.
we have to research on. Just suppose I have a paper of the data sort. Okay, I will find the data sort by searching on Google. In this paper,
I
there
think the question is about that. The author, the author.
Yeah, so it's like here, for instance, you have an other search engine. So
okay.
because that's frustrating, that means I can't reproduce the same, I can't follow your path and do as if I would do the state of the art.
Yes, yes.
So So I'm just saying it would be interesting to have the full documentation of the research.
Okay,
So it's 100% reproducible.
no, I have
And
this
I
thing in
think it's
Excel.
good
I made,
practice.
yeah, I
It's
got
very
it.
good practice, which in the industry people don't do, but I think
Okay.
should. And so that's the comment. I'm actually complimenting yours.
Yeah,
I really like that part of yours. And the second part, I think I really like this genetic algorithm approach. I think it's the good approach to use for what you're doing. But I think you don't make a good story of it. You didn't tell us why maybe genetic algorithm is the right way to go. And my intuition is that genetic algorithm allow you to really explore the design space, maybe in a much better way than other approaches would do. Am I right or wrong? Did you think about this? You didn't really share some thoughts about this.
Yeah, you can say maybe not too much detail, just the overview. But we found the other algorithms like I presented in the meta heuristic, especially like the hill climbing or simulated annealing. I can show that.
Yeah, but these approaches probably would bring you fast to some place in the
Yes.
design space, but not allow you to explore.
Yes, exactly.
So I think that's why it's, but maybe it's, well, we need some thinking, but it would be good to have some, strong arguments
Yeah.
for genetic algorithms here in that type of research. Because I think genetic algorithms suffer from other approaches in AI these days.
Yes, yes.
But they have nice qualities. And I think
Yes.
here they're the right way to go. So
Okay.
really, you should really think more about this. I'm not sure if there's a paper that could come out of that. But, I really like that. So, but you
I will
didn't tell
keep in
us much about this. So maybe you just went to genetic algorithms and into the, technical details of it. But, take a step back and look at your work. So,
Okay, I will.
okay, and I have other comments or questions. They're more perspective, but you already touched at that in your conclusions. So I played a bit with your app. It was hard to find the URL in the manuscript. It was not obvious, but I found it.
Okay.
And I played with it, and as a vid user, my first reaction was to try to interact with the visualization, but then I was frustrated. There's not much interaction in there.
Yeah.
So you can, but I'm sure you thought about it. So,
Okay.
so you mentioned this, like, for instance, there are systems where the user can drag and drop things or select things. So that's the first thing you want to do. You want to select. You imagine that since all these visualization are built on the same data set, selecting something in some view would be coordinated with some other view. So the whole dashboard is a multiple coordinated views thing, but not really, since you can't really act on it. But I'm sure that's the next step
Yes,
on your
exactly.
wish list. But then my thinking was, okay, let's not maybe imagine everything you can do with the viz in terms of, enriching the dashboard with interaction. And you mentioned other operators stuff, which would come to mind. But could you, into the genetic algorithm itself, bring in something that would take the user tasks into account and feed the genetic algorithm with choices to make depending on what task the user would like to conduct. And there you could use frameworks like, I was thinking about the one by Münzner and Bremer, where you have these tasks like, can't remember exactly, explore, search, query. I'm not aware of that paper work. They have this why, what, and how, and thing. They have this very nice taxonomy. So, what's your feeling about that? Could you kind of integrate into the model behind the genetic algorithm user tasks? If you have a nice taxonomy, could you take this into account? Like,
Yes.
if the user would like to do this, then it's that visualization that's a better fit. Maybe the algorithm would deduce it itself, or propose things, and you kind
Yes,
of
I got
go
you.
a step further into
Which could be.
building the dashboard.
I think this could be in which, for the moment, this is completely automatic. Okay, but like we define templates or something like this, where we can ask user for the questions like you are saying, what they can do more and explore.
Okay, but what's behind the template now?
Like we will make some, let's suppose I have my data of the medical or sports. I will select that type of the data, that template. And now I can say I want 5 utilization or something like this and their layout. We can propose them.
Okay, but that's not taking a task into account. If that my task is to highlight some trend or find outliers or stuff like that, then that could condition
I got
what
you.
visualization would finally be best.
Yes. So maybe we
That
can
could
get
change the
some,
whole game.
we can add some more here, new options.
Yeah.
At the bottom.
So then you could rely on some.
What you said, I remember in data sort, they did these things.
Okay,
Like this. Data sort and Calliope also.
okay,
Mostly they play with the outliers and they use the statistical properties of the data set.
okay. And
And
you
completely
readily
based-
see how you could take that into account into the genetic algorithm itself?
Yeah,
Like with crossover and mutation stuff, I'm not.
yeah, it is here we can take into account,
Yeah.
but we didn't try to implement or think in more detail.
Okay.
But in my perspective, I think it is possible. More time and more things
And
resources can be provided.
And, and even laying out all these views with one another, since they would be
Yes.
closely coordinated in terms of interaction, maybe the layout itself could be deduced from the.
Yes.
algorithm. That would be really neat. I think that would be a winner.
Yeah, for the moment also we didn't work more on the layout optimization. Just we keep very simple layout. The size of each dashboard or the visualization, we keep only fixed that I can show you here. Like for the moment, you will see everyone of the same size. Okay.
Yeah.
But when you will click on it is not working. Because we don't.
The layout would be.
Only you can make them top to bottom based on the complexity. So these two features, if we could have a more time, we
Okay,
can
so
work
you
on them.
already thought about that. It's only a wish list.
Yeah.
You have work for the years to come, like.
Yeah, exactly. Yes.
But it's a very, very nice topic and very nice problem to solve. I think we're ready for that.
And one more point to add, one of the students in Bilwa, he was the master student. She also tried to work with me on the layout, but we didn't find very productive thing that I can integrate in the system.
Yeah, and I think the timing is good for you. I tried to run a project, start a project with Viz. It was network Viz, but that's not the point. Something like 5 years ago. 5 years ago, everyone was looking for AI. AI was a solution to everything. I mean, you could forget about the user and the human in it. And I think now people are, the hype is going down. So I think bringing back ideas like the ones you're working on is probably it's the right time to go back to people and say AI is really great, but AI with something where the human has control is even better. I hope you succeed doing this. I'm really happy to see you have success with that. It's really, really good work. I'm really happy to be here this morning. Thank you so much. I will now lend the microphone to whoever wants to talk first from your team of advisor. Fatma?
Thank you. First, I have no questions, but congratulations for this work. It was a pleasure to me to co-advise your thesis. We have the research aspect and applied ones, and especially the implementation of SimpleVis, which enable to reach the goal of an INR project, BI for people, because you show that it's a help for especially novice users, and congratulations.
Thank you so much.
Thank you. Kevin.
So first of all, I would like to thank all the jury, external examinators and reviewers, and for the comments and for the discussion. And I have also to thank Jill and Fatma, because in the departure I was not implied in the project, And when Praveen has been selected, Giles say, "Hello, Cyril, can you come in?" And it was a pleasure for me to collaborate with Gian, Praveen, and Fatma. And was really appreciate the collaboration with Praveen. He's a hard worker. He's also, you say it, a technician, a programmer. He designed the web app, and with a lot of things and with new technology for him also. So congratulations for the work done and for the. I have just a few comments for your things about the GA and how to improve the GA, or how to integrate user implicit preferences in GA, because previous student of mine to make a work about how to use the implicit preference in GA, and we can use several things like also machine learning approaches in order to configure how to the genetic algorithm should prefer the type of visualization on another one to different tasks. We can do things like that, but not for the visualization. It was for another problem. But we can do this in GA by configuring the probability of mutation according to different profile and to different tasks, something like that. That's a kind of solution. But I was really to finish with your PhD. I was really impressed by the tool and by how you handle the development of the tool and how we improve it with the child commands and how you make it a good tool. It's what say that the tool is beautiful. It is beautiful. The scheme, the all things, the visualization, and we have still work to do about the layout, how to because we have the preferences about the attribute, but we don't have the preferences about the attribute is not represented in the layout. So in order to focus more on the preferred attributes with more larger places than others, something like that. It's a very difficult task, but it's very interesting to do. So I think we have still work to do on the preference, also to analyze the user preferences, to make to adapt to the user's past things. So we have to record the sessions and to think about that. But yeah, it's an open solution, and I think the work done by Praveen is very good and very strong in terms of programming and in terms of abilities to evolve. So congratulations, Praveen, and yeah, you are an engineer and you came to research. So congratulations again.
Thank you so much.
Okay, Praveen, before I talk about you, I would like again to thank the jury for being here. Thank you, Anand, for suggesting the active learning. I think it's a good idea, yet we don't have a history, as said Praveen. We don't store things about users, but if we start to do this, then you can use those information to learn something, and there are some systems, said Praveen, are doing this. Arnaud, just one very quick comment about the gamma coefficient. In fact, it has an influence even if the complexity value are all equal, because it introduces a small penalty that is proportional to the number of visualizations. And the idea was that if the requirements of the user can be satisfied with 3 visualizations, it is useless to propose 4 or 5. So it's a very small penalty, but I think the GA can be sensitive to that and propose a smaller number, even if it's not an important penalty. And for the other tasks that we suggested, maybe by experience, unfortunately, it doesn't work, but I think that the questionnaire you implemented, Praveen, in the interface could be used for that. I mean, people can say if they were satisfied with whatever task they have in mind. But I know the experiment with VisAssist, the previous system, in general, they don't answer. They answer a little bit, but not so much. And Guy, about the use of task and another point, thank you also for the suggestion. In the previous system, in VisAssist, it was a system that was suggesting only 1 visualization. It was very different. There was no GA. And there was, for each visualization, we tried to evaluate which tasks were solved by this visualization. And when the user was saying, I want to find outliers, then the system was trying to find the visualization with a good score on the outlier task. But again, those scores were given by our own knowledge, you know. And now I come to you, Praveen. It was a really great pleasure to work with you. A very good sign is that we would like to continue this work, but you know, a PhD is only three years, and that's life. And it was very good to work with you. I suggest something that we would do. Give you an example. In a few months, we will send an email to the SimpleVis list, which is the American and international list about information visualization, because I would like to share my own experience very quickly about the VisAssist system. I sent a message on that list, and that's a very interesting property of your system. And I got some feedback, only one, but it was Ben Schneider. He answered me, and I know why he answered me, because this person is very well known in visualization, and Ben Schneider has created complete systems in visualization, especially machine. He's well known for tree maps and so on, but he did also some work on complete systems. And I think one very interesting property of your system is that it's a complete system. You can really start from the data, and you obtain a result, and you can download it and use it. See? And that's a very good property of your system. And as said, Cyril and Fatma, you did a really good work on the user interface, among other things. And I think we will have to send an email once we have submitted the paper. Not before, but we can send an email to that list, and this will give you a lot of advertising about. And congratulations again, Praveen. It was really great to work with you. And what Praveen didn't say is that he's got plenty of ideas for creating startups and companies and so on. So you already started a little bit in this direction. And I wish you really good luck for your project and so on. So thank you again for your work. And also, I think in the BI for People project, this was one of the major results in the project also.
Yes, yeah.
Thank you
so much.
Yeah.
Well, it's time for us to gather in a private room, discuss and decide of your future.
Okay.
That's tough job.
Thank you so much to all the
We'll be
members.
back in
Annelle, tu nous rejoins pour l'autre lien que j'avais envoyé, s'il te plaît? On va se
Oui,
connecter dans.
je me reconnecte, oui, je me reconnecte sur l'autre, oui.